In this part of the episode, I would like to talk to you about rounding. So, a situation where you might need to do some rounding, you might see a grade scheme that says if you get 84% overall in this class, I'll convert that, for example, to a 2.7 in your transcript. And if you get an 83%, then that'll be converted to a 2.6 in your transcript. Now, if this is in your syllabus for one of your classes and you get a score like 83.2%, the question is, what is your teacher going to do with that? What is going to show up in your transcript in this situation? Well, one of the ways that that question is answered is rounding and taking this decimal number and basically converting it into the whole number that is as close to 83.2 as possible. And to give you an example of how rounding works, suppose somebody said convert 13.4 to the nearest whole number. Now, if I draw this on a number line, I might have the number 13, the whole number 13 over here, and the whole number 14 over here. Now, between 13 and 14, there are a bunch of decimal numbers in between. For example, if I add 1/10 to that, I'll get 13.1. Another tenth would be 13.2. Another tenth would be 13.3. Another tenth would be 13.4. Another tenth after that, 13.5. Another tenth after that, 13.6. Then 13.7. Then 13.8. Then 13.9. And then if I add one more tenth to that, then it will roll over and I will have 14, the whole number 14 from that process. Now, if I put a dot on this number line at 13.4, and I ask myself, literally in this picture, what whole number is as close to 13.4 as possible? I can see that 13 is just a little bit closer to 13.4 than this number on the other side, 14. Here, the distance between 13.4 on the left is just a little bit smaller than the distance going to 14 on the right. So the literal nearest whole number in this situation would be the number 13. That is the whole number that is as close to 13.4 as possible. What if, for example, I asked that same question, but about the number 13.7? If I mark 13.7 on this picture, 13.7 would be located over here on the sort of right half of this picture. And now if I ask myself, what whole number is as close to 13.7 as possible? The nearest whole number would be this one, 14, on the right side. 14 is much closer than 13 is in this case. So 14 would be the nearest whole number to which I would round 13.7. Now, this question becomes a little bit more challenging if instead of 13.4 and 13.7, I asked specifically about 13.5, right? 13.5 is located dead center directly between 13 and 14. And so the distance to both of these whole numbers is the same. And so if someone asks you to round to the nearest whole number, the question becomes, which of these numbers do you choose? Do I round it down to 13 or do I round it up to 14? Well, think about this in the context of a grade, right? If you were a student and you had a grade of specifically 83.5%, which would you prefer? Would you prefer your teacher to round your grade up to 84, or would you prefer your teacher to round your grade down to 83? Probably you would rather have the grade rounded up, right? And go up to the nearest whole number. And so that's what we do in this situation. If you're doing specifically 0.5 and you're rounding to the nearest whole number, then in this situation, if we have 5, we just choose and agree to go up. And so, based on that agreement, I would give the person the better deal. I would give them 14 instead of 13. Now, in this situation, we have rounded to the nearest whole number. However, it's also possible to round to any place value. And when someone asks you to round to a certain place value, we can use a process similar to what we have explored in the previous 3 examples. If someone asks you to round to a certain place value, go to that place value in the number and then look at the digit directly to the right of that place. If the digit is anything between 0 and 4, we simply cut off all the digits to the right of the place value that was given to you in the question. For example, someone asked me to round 13.4 to the nearest whole number. So I went to the whole number position, and then I looked 1 unit to the right of that. I looked 1 place to the right of 13. And the digit I saw 1 place to the right of 13 was the digit 4. Because that digit was quite small, all that I did was basically just delete that digit and left the whole number 13 as my final answer. Now, if the digit to the right of the place value is larger than that, if it's 5 to 9, then you still want to cut off all the digits to the right of the place value that you care about. But then you want to increase the digit in the given place by 1 unit. That's really abstract, so let me show you what I mean. When we were asked to round 13.7 to the nearest whole number, the whole numbers end right here to the left of the decimal place. So we looked 1 step to the right of that position, and we saw the digit 7, which is a very large digit. So we got rid of those digits, and then we increased that 13 by 1 unit and turned it up to a 14 instead. And that got us the nearest whole number to 13.7. Let me give you several more examples to show you what I mean. Somebody says round 7.0532 to the hundredths place. So the first thing that I'm going to do is I'm going to go into my value and I'm going to locate the hundredths place. The hundredths place, the hundredths place is located 2 steps to the right of the decimal point. Next, I'm going to go 1 step to the right of that, and I'm going to have a look at this digit 1 step to the right of the hundredths place, and that digit is 3. And that's a quite small digit. That's a digit between 0 and 4. Because that digit is small, I'm simply going to delete all of these digits to the right of the hundredth place, and I'm going to keep the digit in the hundredth place the same, and my final answer is just going to be 7.05. What if somebody said round 7.0528 to the hundredth place? Once again, I'm going to go into my number. I'm going to locate the hundredth place, and I'm going to look one step to the right of that. That's still a very small number, so I'm just going to X and get rid of these last two digits here, and I'm going to leave it as 7.05. It doesn't matter that we had a big 8 here in the back. It doesn't matter because that 8 is not directly to the right of the decimal place that we care about. The only number that we have to look at is the one directly to the right of the decimal place that we care about. Now somebody says round 7.0561 to the hundredth place. So if I look at 7.0561 and I identify the hundredth place, and then I look at the digit directly to the right of that, this digit 6 is a relatively large number. So I'm going to delete these numbers at the end of 7.05, but then I'm going to increase the digit here by 1 unit. And so, rounded to the hundredth place, rounded to 2 decimal places, this value would become 7.06. And if someone said to me, round 7.0532 to the 10th place, then I would write down my number. I would identify the 10th place, which is right here, and I would look 1 unit to the right of that, 1 step to the right of that place. Here I see the number 5, which is on the large half of the digits. So I will delete all of these numbers after the 10th place, but I will also add 1 unit to the 10th place, and that gives me 7.1 for my rounded value. And if someone said round 7.0528 to the thousandth place, now I would look in my number at the thousandth place, and I would go 1 digit to the right of that. I find 8 here. This is a large value. So I would get rid of those digits to the right of the thousandth place. I would add 1 number to the thousandth place, and I would get 7.053 from that. And finally, a final example, if someone said round 7.0561 to the thousandth place, I would identify the thousandth place. I would look at the digit 1 step to the right of that. This digit is nice and small. So I would get rid of that digit, and I would leave what is in the thousandth place the same, and I would do the 7.056, and that would be rounding this number to the nearest thousandth place.